Okay, cool. All right, let's get started. First of all, I am Erik Gross. I have a nice little slide here to let you know bits about me. I'm joining you from a little town called Slidell, Louisiana. That's near New Orleans, so about 30 minutes east of New Orleans, right on that big lake. If you're not familiar with the geography of Louisiana, right above New Orleans is a massive lake called Lake Pontchartrain, and I'm right near that lake. So that's where I am. I'm a senior level software developer, as it says. I've been programming and messing around with computers for a long time. I'm a veteran. I was in the U.S. Navy for 6 years, operated nuclear reactors, and taught all sorts of technical, nerdy things like nuclear engineering and electronics and computers and physics and chemistry and a bunch of nerdy stuff in the Navy. And I'm also the co-founder of the Tech Academy, which you'll learn a bit more about tonight in addition to our free coding class. All right. Now, basic class rules. Please do use the assistant. We have an awesome assistant in the chat, Christine, and her role is really to monitor the chat, answer questions, kind of help both me and you as we go through the class. Please be nice. I don't have any worries about that, but if not, we'll just pop you out of the meeting. I want to stress that because we are going to be doing actual coding tonight, that it can be a little bit challenging. As a student, you might run into challenges, and I want to point out that part of the learning process is working through those challenges. So please use chat as needed. We're also making this very approachable, even if you've never coded before. So do me a favor, drop into chat whether you have done any coding at all. Give me a yes or no as to whether you've done any coding at all. All right, Jawad's done some coding before. All right. And what about Serena, Eliza, Curtis? All good. Let's see. Nico says done some C# and Unity coding. C# is a programming language. Unity is a tool to create video games. That's excellent. And if you're just joining us, just let me know whether you've done any coding at all in the past in chat. It's also just lets me know that you all can access the chat and it's working well. Excellent. Eliza says, I've done a little bit of JavaScript. Fantastic. Curtis is proficient in Python. Excellent. Great. You'll probably enjoy this a lot and probably do pretty well at it. All right, good. So whether you've done code or not, I think this next bit of advice is pretty appropriate, which is please ensure that when we're in the actual coding part, which will start in a few minutes, please ensure that you type the code exactly as written. And the reason for that is that a misspelled word or a missing symbol or even something capitalized that shouldn't be capitalized, these can all result in code errors. And we'll go over a little bit of why in the class, but just pay attention to exactly how I type things and do it exactly as I'm doing it, and that should handle most of the problems. Now, again, as I mentioned, we have at least one person in the meeting who's attending on a mobile device, which means you can listen. So while it's ideal to do the event on a computer so you can actually write code, if you don't have access to an actual full-blown computer like a laptop or a desktop, please still watch this event on your phone. You're going to learn a lot. Even though you won't be able to write the code, you will still learn a lot. And then one of the last things I want to mention is please make sure you're in a distraction-free environment. You can focus on the class so I don't lose you. Also, if you get lost or you can't keep up with the coding, don't worry about it. Stick around and listen because you're still going to learn a lot. Also, this video is going to be recorded in full and it'll be up on YouTube either today or tomorrow. We'll give you the full code. We're going to be working on a game today, and you'll be able to play the game and see all the code in it and everything. And you're also going to get the full code at the end of the class to be able to play the game. And finally, we're going to provide you with all links to our future events, our free videos, and other resources at the end of the event. All right. So I think I've got a pretty good beat on where people are joining us from. See, Eliza and I think Curtis, I think you've been to one of our classes before. If you haven't, let me know where you're joining us from. Drop that in chat. Let me know where you are. I'm near New Orleans. And grab a sip of water. Excellent. Keith is in Denver. Beautiful, beautiful city. That's right. And Curtis, you're in Portland, Oregon. My hometown for almost 30 years. All right. So here's the basic agenda. We'll have a short explanation of the Tech Academy, and then we're going to write code. You're going to get your hands dirty, actually like going through code and not just writing it, but and explain what's behind it, how it works and why it works that way. I'll look for questions during the class, right, in chat, right, and try to pick them up and answer them as they come in. But we'll also, if time permitting, have a Q&A session right at the end when we're done writing code. Then we'll go over some information about our boot camps. And we do have a free gift for you at the end. And it's a pretty cool gift. So please do stick around until the end. The whole class should take about an hour and a half. Let's see, Eliza asks, will a link to the class YouTube video be sent to our emails? No, but even better than that, right at the end, we've got a, I'm not sure if you're familiar with the service Linktree. It's like a link aggregator. You can go to one page on the internet and it's got all of your links. I'm going to give you our link tree. And so among many other links will be a link to the YouTube video channel. And if you just look out there in the next 24 hours, boom, you'll see this video up there. Hope that answers your question. Excellent. All right. So brief word about the Tech Academy. We provide coding boot camps, and coding boot camps are intensive technology certification programs. They're designed to prepare people for entry-level positions in technology. Typically, they'll last 3, 4, 5, 6 months, and they focus on modern, practical skills, the things that employers want. We at the Tech Academy have been offering thorough, budget-friendly, flexible, and trusted coding boot camps for over a decade now. And those programs are cost-effective, and they're self-paced online coding boot camps. They're tailored for beginners, people that have no prior technical or coding knowledge. Our programs cover thoroughly in-demand skills for the tech industry. They're endorsed by stellar online reviews, and they're designed to fit around your personal schedule. We try to prepare you for your technology career with a really well-rounded toolkit. In America, at least, the average cost of these boot camps all around the country is around $13,500. Ours are under the national average, and we've had boot camps that start as low as $5,300. And I always like to read our mission statement because it's why we're doing these free classes. It's why we exist as a company. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. That's our mission statement. Our product is you working in tech. We have a pretty new service that we launched to help you do that. It's called the Tech Academy Accelerator, and it's a monthly subscription program. It includes live weekly workshops with me. More about those in a second. It includes access to over 100 educational videos and over 100 self-paced online mini classes. What's cool about the workshops, these live weekly workshops, is we get to do a deep dive into complex technical subjects. These workshops include Q&A with and voice, so it's a conversation back and forth. And I teach topics that are suggested by the Accelerator community. We constantly ask, the members of the Accelerator community what they want to learn about, and I speak to that and teach that, right? Cool thing about it, it's really inexpensive. It's $9.99 a month for this, and you can try it out for your first 7 days free. And I will drop, actually, Christine, if you don't, go and drop the link to the Accelerator. There it is in chat. So if you're interested in trying that out, go ahead and click on the link and fill out the form. It's pretty simple form and application process. It does ask you for a card number, but you're not going to get charged. You don't get charged until a week has gone by, and you can cancel anytime. So what I recommend is sign up, attend that first workshop, which is next Tuesday evening, and you're not going to get charged until a week from now. So there you go. And we talk, like I said, well, people are filling this out if they want to. These workshops are a blast. One of the more recent workshops we did that I really enjoyed was teaching people how to be an effective freelancer. Like, you break into technology and you've got that first job, which is great. But after a little while, maybe you want to produce a side income doing small, like one-off projects or custom software development. How do you manage that? How do you make enough money from it that it's worth your while? How do you charge enough? How do you set up the business? How do you make sure that you're not getting taken advantage of on the pricing? All this kind of stuff, which is really cool. And of course, as a member of the accelerator, you can watch all of those previous workshops and pick up on all that data. All right, now let's get into coding. Here's a little bit of preparation we're going to do before we actually start coding, which is that it's important to understand your terms. So the first thing is just, what's a program? Well, a program, we're all used to using programs like Microsoft Word, or maybe a video game like Diablo 3. These are programs, but there's a different look at it. A program is a series of written instructions, a set of written instructions that can be entered into a computer that make the computer perform certain tasks. So what we're talking about here is something that you, as a technology professional, can create that will help other people perform effective tasks. So that's a program. Well, the next thing is a programming language. A programming language is an organized system of words, phrases, and symbols that allow you to communicate with the computer. And you can tell the computer what to do. Programming languages are what we use to write computer programs. Another definition is coding. Coding is the action of putting those instructions into the computer. When you're doing that, you are coding. You're putting the instructions in that will make the computer do what you want it to. And then as a noun, code is those instructions themselves. You might say to another technology professional, hey, come look at this code on my screen. It's not working. Can you help me figure it out? Or you might tell your boss, I've been coding all morning. I kind of need to go grab a cup of coffee and take a break. Right? So these are the words involved. All right, now who has already got proficiency in Python, which is awesome, right? And probably knows a bit about this. It was developed over 30 years ago, almost 35 years ago, by a really talented Dutch programmer, Guido van Rossum. He worked at Google for many, many, many years. And he created Python to be a very easy to learn, flexible, but very powerful computer programming language. And he succeeded. When you read Python programming code or write it, it reads very much like English, as you're going to see tonight. And it's, like I said, it's really flexible and powerful. You can use it to create all kinds of different computer programs, like applications, websites, games. Python can do a lot of different things. So that's an introduction to Python. Now, this next slide, I'm not going to switch it until I set you up for what we're about to learn. We're not going to jump right into coding. In fact, what we're going to teach you before you even write a line of code is the fundamental elements of any computer program. It doesn't matter what computer programming language you're using. A program will be made up of these 5 things we're about to teach you, and only these 5 things, which means that these next 5 things you're going to learn could be a really solid foundation for you in both computer programming and a tool to learn any new programming languages. So enough preamble. Let's start looking at these 5 elements of a computer program. The first one is an entrance point. This is really the first instruction of the program. In other words, if you have a program on your computer that's not running and you tell the computer to run the program, usually like you find the little icon and you double click on it or whatever. If you tell the computer, hey, please run program X, well, the program needs to have the first instruction that the computer is supposed to do. The computer needs to know, okay, when I'm going to run this, where do I start? What's the first thing I do? Now, that seems pretty obvious, and it is pretty obvious. It's pretty simple. Of course, where do you start? But it's why this is valuable for you to know as a technology professional that I want to talk about. Let's say it's like a year from now, and you've broken into technology and you're on the job and you're a software developer and you move on to a team and they have a big computer program that they're responsible for maintaining. They fix any bugs in it, any issues. They add new functionality to it. If they need to protect it from any new security vulnerabilities, because the internet is the wild, wild west sometimes. If they need to protect it, they're responsible for that. In other words, you're joining a team that's responsible for a very large program. One of the first things you're going to want to do is go into that program, into the actual written instructions, and start to figure out, what are they? How does this program work under the hood? And it's for that reason, it's for this situation, that knowing that there is an entrance point, knowing that there is a quote unquote first instruction, starts to be really valuable. Because if you know that about the program and you can find that first instruction or first few instructions that are going to be performed, you have the most logical and most effective place to start reading through the program and start to begin to gain an understanding of, how does this complex thing work? What's the very first things that happen as soon as you turn the program on? Now, there are other reasons why, knowing the entrance point is really valuable. But the point is, your program has to have an entrance point. There's another facet of it I want to tell you about that isn't related to you, but it's related to your computer. You put a computer program onto your computer and you want to run that program. Well, what is it inside your computer that actually lets that happen? Lets you put a program on and run it. If you don't already know, the thing that lets you do that is a very specialized program called the operating system. And we all know the operating systems, whether you know that's what they're called or not, because they are Windows, Mac OS, and Linux. Now, there are other operating systems, but those are the three big ones in the world. Windows is an operating system. Mac OS, or Mac operating system, is an operating system, that lives on MacBooks and MacBook Airs and the Mac desktops, right? And then Linux is an operating system that lives on laptops and desktops as well. So these operating systems, we're not going to go into detail on what they do, but I'll tell you one really important thing they do, and this is all related to an entrance point for a program. The moment you start a computer program running on the computer, that operating system needs to do something that's very important. Inside the computer are a bunch of small devices where you can store data that the computer program needs to store and gain access to. They're little teeny devices. They're called memory sticks. Also called RAM. You probably heard that term. Well, having a little device inside the computer where you can store the information the computer program needs access to makes sense. But what's really important is, you don't want the data that one program is accessing in this storage area. You don't want that data to be accessed by another program and come in and overwrite it and change it. In other words, you want to reserve some portion of the available storage area for this data that's dedicated only to the computer program that you just started. And so it's important to know that there's an entrance point to a program, because that's what signals the operating system to say, hey, program X just started. I need to reserve some data storage area just for program X. All right, now we'll come back to that later on. Now let's look at the second element of a program. It's what's called a variable. And a variable is just something inside a program that can keep track of data that might change as the computer program runs. We'll have more on that in a moment. You're going to make that. You're going to write code for that. The next fundamental element of any computer program is what are called control or branching points. This is some way inside the program for the program to make a decision. It's where you have two or more possible things that could occur, and you need to have a way to tell the computer how to decide between those two or more things. Which one of those two or more things will happen? That's a control and branching system. And so a program has to have this. Your program's got to be able to make decisions. And again, you'll build some of those tonight. The other key element, another key element, again, there's only 5, of a computer program is what we call subprograms. And as you can see, these are considered programs within programs. Now, like I said, you're going to build some of these tonight, but I want to explain a little bit of background. Let's say it's 50 years ago and you're at the dawn of computer programming, and you're a programmer writing in programs, and you find while you're writing a certain program that there's a certain series of instructions that you end up repeating over and over and over again. They're identical each time. Let's say there's 5 exact steps that those 5 things are needed to be done over and over and over again at various times while the computer program is running. Well, that's a problem. It's not a problem that that series of steps needs to occur. What's a problem is that each time you type those out, there's a possibility of error, that you don't get it exactly the way it was done before every previous time that you entered the instruction. But the other problem here is that it's a lot of work for you to do the same thing over and over again as a programmer. And the final problem is this. Let's say later you come up with a different way, you come up with a change to those 5 identical instructions that are repeated maybe dozens or hundreds of times in your program. You come up with a change that you want to make to how those 5 instructions get performed. Well, now you have to go back through your program and find every single occasion where you put that exact series of instructions and make the change over and over and over again. And it's very time consuming, very error prone. And this is what actually occurred 50, 60 years ago as computer programmers were kind of figuring out how to use these machines, these computers. So they came up with the concept of a subprogram. They said, okay, I've got this series of 5 instructions that I keep repeating over and over again in this particular program. Why can't I just have those 5 instructions go into like a little box? Like it'd be a little subprogram that has a name. And then every time in my main program that I want those 5 steps, for example, to be done, I just say, hey, do the subprogram A, or whatever name you give for it. And it'll work that way. The program comes along and hits the point where it's told to do subprogram A, and it jumps over to subprogram A and goes, oh, let me do this 5 things. 1, 2, 3, 4, 5. And as soon as it's done, it goes back where it left off and continues forward in the main program. That advance, that concept being implemented in computer programming changed the industry. I know I'm talking it up a lot, but it's a powerful element of a computer program, and you're going to build some tonight. All right. The last thing I want to cover is the fact that every single computer program needs an exit point. It needs a final instruction. And one of the primary reasons why is, remember how I said when you turn the computer program on, the operating system is going to, reserve some of that memory storage where it puts data. It's going to reserve it just for your computer program. Well, when your program's done running, the operating system needs to be told this program is shutting down. You no longer need to reserve that memory storage area. And that's a big deal, because if you didn't do that, all that memory is inaccessible to the other programs on your computer until you turn the computer off and on. So these 5 elements, the entrance point, variables, control and branching, subprograms, and exit, these are the only elements of any computer program, no matter the complexity, no matter how big or small. Now, they're not done in this exact order. When you look in a computer program, you'll see these various elements being used all over the place, but this is really all there is in a program. And so you're going to learn how to make these things tonight. All right. Now, to do that, you're going to need a place to enter in the instructions. Christine, if you could drop the link. There you go. Look at that link that went into chat. I'd like everybody to pop that open. That's going to take you to a code editor, a place you can enter code, a place you can enter instructions. And it'll look like what you see on the right, where it says students code. That's what you're going to see. Now, there'll be some existing code in there. Don't worry about that for right now. We'll handle that in a second. But here's what, this is really important. Once you've clicked on that link and you've opened up that code editor, what I need you to do, and this is only if you have one monitor. If you have 2 monitors, you're going to be fine. I need you to be able to see my screen and your code editor at the same time. So do some sort of split screen, half on the right, half on the left. I'd like your code editor, yours, to be on the right. Mine will be on the left. And how will you do that? Well, you're going to move the Zoom meeting to the left, because that's where you're going to see me and my screen. Sometimes that might be a pain. If you're having trouble resizing and moving the Zoom window around, you can click on the word Zoom meeting and a restore button will come up. And then for the browser where this code editor is, sometimes you might need to click on this funky little symbol here that lets you resize. But either way, I want you to set it up so that on the left is me and on the right is the code editor. And we're going to start coding. So let me go ahead and stop sharing for a second and set up my code editor. Get everything going. All right. And I think there we go. All right. Share my screen again. All right. Let me grab chat. Let me know in chat if you can see my code editor. All right, good. Okay. Now, the first thing I want to show you is the game. This is a Connect 4 game. Don't worry about this code. You're going to get a copy of this for you. If I enter this in and hit run, over here on the right is where we see our output. So again, don't worry about all the code you see on the left-hand side. We're going to examine that in detail later. But you can see it's a game, and it's got a little user interface, and I am player X. And so I need to drop, if you haven't played Connect 4, I'm not sure what to tell you. One of the best games in the world. I need to drop a game piece in one of these columns, and I'm going to go with 3. And so suddenly it'll rewrite it, and there's mine. And then the computer's turn was to put one right here. All right, I need to choose a different column. I'm going to go with 4. All right, and the computer's turn, put 1 on top of me here because it's an idiot. So now if I do this right and I go with 5, I should lock down the game. Computer, Did I hit enter? I think I have a bug. That's fine. All right. So let me show you. First of all, on the left, this is all the code to run this game. Now, there's a lot in here. Like I said, don't worry about any of this detail right now. I just want you to see this is what the game's all about, okay? And I don't actually think there's a bug in my code. I think there's something wrong with the code editor. I see that occasionally, but that's minor. Don't worry about it. On the left here, like I said, is all the code, and you're going to get a full copy of that code. But for now, we're going to erase all that. And I want you to erase everything that's in yours. Yours has like an import kind of thing and a bunch of other green letters. Erase all of it. Give me a yes in chat when you've erased everything and you're ready. Drop a yes in chat. There we go. Heath Curtis, Jawad, Nico. All right, excellent. Okay, so the first thing we're going to do is just have an entrance point. In other words, we're going to have a very first instruction. We're going to just print something on the screen. In Python, the command or instruction to print something on the screen is, oddly enough, print. So all lowercase, type print, P-R-I-N-T. Don't hit space. And then I want to explain what comes next and why. Print is what's called a function. It's a built-in function. It's part of the Python programming language. Many functions, in order to do their job, need to be given some information. And print is no exception. In order for this print function to do its job, it needs to be given the information to print on the screen. Again, relatively straightforward. How do you format that? How do you type that out? Well, when a function of any kind needs some information in order to do its job, that information is put in parentheses immediately after the name of the function. The name of our function here is print. So we need parentheses. So go ahead and type an open and close parentheses. You may have noticed that this code editor completes the second parentheses for you, the close parentheses. So what we put inside these parentheses will print on the screen. What information do we want to print on the screen? Well, probably some words. Why don't we say hello world? It's been used for decades. It's pretty simple. But the way you give this text information, the words hello world, the way you give text information in Python is you put the text inside of double quotes. So just to the left of your enter key, if you hit the shift, is the double quotes. So go ahead and put those in there, like I have. And inside here, this is where you put what you want to print on the screen. We're going to say, hello world. Or you might want to spell it correctly. There you go. When you're done with that, we're done with our first instruction. Go ahead and click run above here. And it works. So let's talk about variables. We're not going to spend a bunch of time on the first instruction. Let's talk about variables. Let's say for our game, we want to be able to keep track of the names of the two players. So we also want in our game for players to be able to change their name while they're playing. That means we need a variable. We need a way of keeping track of data, in this case, a player name, data that can change while the program is running. We need a variable. In Python, when you want to create a variable, you literally just start by typing out the name you're going to give to this variable. Think of it like this. The variable is like a bucket that you can put some information in. You can put something into the bucket. On the outside of this little bucket is the name of the variable. And on the inside of the bucket is the actual information. So we need a name. In this case, we want player one. So Go ahead and go to the end of the screen here. Sorry, go to the end of the line, hit enter twice, not because it does anything at all, just for readability. We want to skip a line. You don't have to skip the line. Our code will work the same. It just makes it easier to read. So now we're going to do this variable thing. Like I said, you start by putting the name of the variable. So our variable is player1, Player, and we'll do the number 1, and then hit space. And let's talk about what happens. Now, we're not done with this line of code, but before we go to the later parts of this line of code, I want to explain to you what happens just because of what we typed right here. What does Python, what does the language do with this single word? Well, here's what it does. Python reads this word and recognizes that it's not some sort of built-in instruction in the Python language, and therefore knows, because of how Python was created, Python knows, oh, this is the name of a variable. And Python does something very exact at that moment. And what it does is actually really cool. Python connects to the data storage devices in the computer, this memory device like RAM that we were talking about. It connects to that memory storage device and it finds an exact area, a location inside that memory device. Because all these locations where you can store data, they're all uniquely identified. And it finds a location and it gives that location a name, a unique name, so that that location and the data in that location can always be located later, can always be found. And that's what happens when you create a variable. In fact, the technical term is called declaring a variable. Just by typing its name, you've declared the variable. We're not done yet. What we have right now is we have a bucket with a name written on the outside of the bucket. What we don't have is anything inside the bucket. In other words, we have a location in memory with a unique name, but there's no data stored in that location. What we can say, if you look at the precise terms, is our variable doesn't have a value. It doesn't have any data stored in it. So let's do that. You do that with a special symbol, a Python symbol, that is the equal symbol. So hit equal, and then give me a space. This symbol is actually a Python symbol, and it tells Python to do a very specific thing. It says, hey, look to the left of me, look to the left of this symbol, and find the variable to the left. Then look to the right. Now, we haven't typed anything yet on the right. We will. It says, look to the right and find whatever value is there, whatever data or information is there. Take that information and store it in the variable on the left. So let's put some information in there. Just do double quotes and type your name. I'm going to put Erik. Of course, I'm going to have to click over here, so I'm actually typing there. Like that. You put your name. Now, I want to stress something. This is really simple. I'm not looking at complex code here. But there's a lot of very important programming things going on just with this one line of code. The programming language Python is able to look at the first part of the line of code, recognize that that's a variable, and then go into the memory of the computer and reserve some of that memory just for this variable called player1. It's able to attach a unique identifier to that, location in memory. And that unique identifier is the word player1, all with this one line of code. And then with this second part, it's able to store some data in that location. And by the way, the technical term for that is called assigning a value to the variable. So here on the left, we declare a variable. And on the right, we assign a value to the variable. Those two things are repeated over and over and over and over again, hundreds or thousands of times in every computer program. And it's two operations: declare the variable and then assign it a value. All right, let's use this variable. Let's print it to the screen. The way you do that is use that command print again, P-R-I-N-T, and use the open and close parentheses. But instead of putting something in instead of putting some text to print, and that text being inside of double quotes, you can just use the name of the variable, P-L-A-Y-E-R, and the number 1. And what Python does is it does that same print instruction, but when it gets inside the parentheses, it goes, oh, what have I been given here? What have I been given? Well, I've been given the name of a variable. Well, it's not going to print the name of the variable. Go ahead and run this, and you'll see it'll print your name. So this instruction doesn't print the name of the variable. It doesn't print player 1. It prints the value that's stored inside that variable. All right. Well, watch this. What if your name isn't Eric? Or what if I change my name? Go ahead and hit enter a couple of times. And let's change the value. You can do that by typing the same variable, player 1, and let's assign it a new value. Dave. There we go. Everybody call it Dave. And then let's print this again. P-R-I-N-T, player 1. And run it. We now have a variable, player 1, that can keep track of data that can change as the program runs. Now, I know these are very simple examples. We keep it simple to make sure that the concept is the important thing to concentrate on, not some complexity of code. There's no need for that. All right, good. Now, what's the next element? Well, it's what we call control and branching. This is where you can tell the computer to make a decision. So let's look at a decision that we could talk about that the computer is going to need to make. Every single time one of the players, either the human or the computer, every single time they take a turn, the computer is going to have to decide whether or not a player has, in fact, 4 in a row. That's a decision we're going to need to make over and over and over again. So let's write a simplified way to tell whether or not there are 4 in a row. To do that, we need to have a variable that keeps track of how many pieces, how many playing pieces are in a row. In other words, your player X, how many X's are in a row? Or your player Y, how many Y's are in a row? Okay. Or actually, I think it's player O. Yeah, we have X and O, right? So let's choose player X. We want a variable that keeps track of how many pieces does player X have in a row. So we need a variable for it. Let's make a variable name. Now, I don't believe in using variable names that don't communicate well. We could use a variable name. Let's hit enter a couple of times. We could have a variable name that just was the letter X. You can do that, but that doesn't communicate well. And if you come back to this code in 6 months and are trying to figure out what it does, that variable's name isn't going to be helpful. Or if another software developer tries to read your code, it's not going to be very clear what you mean. So Let's use a variable name that communicates well. Why don't we use player and then X in a row? I kind of like that. Player X in a row. That communicates. How many pieces does player X have in a row? That's our variable. We got to give it a value to start with. Let's say it's 0. Just assign it a value of 0. All right, now we have not yet written anything about control and branching, but we need to keep track of it in order to even write a control and branching. So now let's get to control and branching. We have to figure out whether there are 2 or more possible courses of action that could occur. When I, as player X, make a move, like drop a piece on the board, there is a decision to be made. And that decision is, now that that piece has been played on the board, does player X have 4 in a row? If they do, then they won the game. If they don't, then it's player O's turn. Remember, we have 2 players, player X and player O. So this is a perfect situation. We have to make a decision, or we have to get our program to make a decision. And the decision is, the way the decision works is check to see whether or not player X has 4 in a row. And then if they do, tell them they won the game. And if they don't, then move on to player O's turn. Very simple. 2 different things that can occur. Let's write that. Let's set up the control first. The control is where we make the decision. A very common way of doing that in Python is by using an instruction in Python called if. So type if, do not hit spacebar, and then I want you to do an open and close parentheses, and we're just going to talk about this for a second before we write any more code. If you've been paying attention, you're probably gathering that inside these parentheses, we need to give some information that the if instruction needs in order to do its job. Remember, we talked about that up here when we said the print instruction needs some information in order to do its job. And this is no different. The if instruction needs some information in order to do its job. But it's the type of information that's very different here. With the print instruction, the type of information that was needed was just either some text or a variable that had a text value. But what do we need inside here? What we need is a condition that the computer can check. What do we mean by a condition? Now we get into a little bit of logic. We need something that is either true or false. That's what we need. No iffy, wishy-washy, mostly true, mostly false. No, 100% cut and dried, true or false. That's what we need. Because this is a fundamental thing about computers. They're stupid. Computers have no intelligence. If you've been paying attention to recent news and looking at stuff about artificial intelligence, you may have gotten the idea that maybe computers have intelligence or can think, and they don't have intelligence and they can't think. For a lot more on that, go to some of the free YouTube videos we were talking about. And over the last couple of free months, I've done several on artificial intelligence. I'm here to tell you, computers can't think. But more importantly, computers can only do one thing at a time, and they can only do exactly what they've been told to do. So we need a way to tell a computer with no confusion exactly which of two different sets of instructions should be performed. That's what a condition is all about. A true or false. That's what it's all about. So we're going to build the condition, which is going to be right inside of these parentheses. We're going to build it from the inside out. Follow me here. Make sure your cursor is still inside those parentheses and hit the space bar once. And then hit the equal sign twice. And then hit the space bar. Now I said we're going to build this from the inside out because when you're dealing with conditions, that's the best way to think with them. Right now, we're going to figure out whether something's true or false. And so we're going to compare two different things. There's lots of comparisons you can make. And to learn a lot more about that, you can go through our boot camps. There's lots of different things you compare. Are two things equal? Is one greater than the other? Is one lesser than the other? That sort of thing. There's a lot of logic you can look into here. We're going to keep it very simple. Right now, we're just going to check whether two things are equal. And when you look at this symbol right here, these two equal signs side by side, this is actually an instruction to Python. It tells Python, the Python programming language, it tells it, listen, on either side of this symbol are two pieces of data. Compare them and tell me whether they are identical or not. This is an actual instruction. Now, especially when you're starting to learn to program, it can be very easy to confuse this symbol, which is two equal signs side by side, with this symbol, which is one equal sign. They have nothing to do with each other. The single equals sign is an instruction that says assign a value to a variable. The symbol with two equals is an instruction that says compare data on both sides of this symbol to see whether they're equal. So let's give it the two pieces of data. On the left, we're going to have the variable, which is player X in a row. Player X in a row. Make sure you type it exactly the same as you did before. Because this is how many pieces does they have connected in a row. And on the right, we have 4. We want to see whether or not they have 4 in a row. Because if they do, then yay, game's over, they won. If they don't, well, now it's player O's turn. So, how do you build that? Well, the way you build it is this in Python. We have a control instruction right now. We have an if, which is a control instruction, and we have a condition that can be evaluated, that we can tell, the computer can determine whether or not this is true. Well, now we need to put down what to do if it's true. The way you do that in Python is you put an equal sign at the end of this line, and then immediately underneath this line, you put what to do if it's true. But this is a super important point. The way that Python can tell whether or not an instruction underneath here is the thing to do if the condition is true, the way Python knows that that is the instruction to do is if the instruction is indented, if it's popped over 2 spaces. So watch, when you hit enter here, go to enter, notice that this editor, just because it's friendly, automatically moves the cursor over 2 spaces. And it's this place on the screen, this place in the code editor, we need to put the instruction that'll happen only if the condition right here is true. Well, what are we going to do? Well, there's probably in the real program some more complex logic, but for us, we're going to keep it simple. We're just going to print, yay, player X wins. So do a print, and you put it in parentheses, put it in double quotes, say, yay, player X wins. But spell player X correctly. Now, what's going to happen when we run this? Don't run it yet. I put into chat what you think is going to happen when we run this. Go on, drop it in the chat. What do you think is going to happen? What's going to print over on the right-hand side? Keith says an error. It's a really good guess. Let's look. Go ahead and run it. Nico said nothing. And that's more of an accurate answer. Nothing occurred. It still just printed the things we had already told it to do. Remember, here we told it to print hello world, so it does. Here we told it to print player one, and the value of player one at that time was whatever your name is. And here we told it to print player one again, but we had changed the value to Dave. And here, it doesn't print this because the value of player X in a row is not equal to 4. All right, well, I'm going to talk briefly to answer Keith's question. Well, it wasn't a question. Keith's answer was an error. You know, that would make sense. Python is a little more forgiving. The reason it might make sense is, let's think about this logically. We have, in fact, told Python what to do if player X in a row equals 4, but we didn't tell it what to do otherwise. It would not be a mistake to think that you might have an error, but Python was built to be very friendly. It's not going to throw an error, but it also means that you need to pay attention and realize, oh man, we didn't tell this program what to do if the number of pieces player X has in a row isn't 4. So let's do that now. Go to the very end and hit enter. And now this part's super important. Don't type this in, but we're going to use another special instruction in Python called else. And if you have else right after an if, the else helps you control what to do if the condition is false. But don't type it where the cursor is right now. Now, do not type this. I'm going to type it for a second, but don't follow along. Else. Now, can someone put into chat why you would not want to start typing that word else right here? Anybody have any ideas? And spend a little bit of time on this because when you're just starting out learning to code in Python, it's a pretty common mistake to make. So I want to talk about it. Anybody got a guess on why you would not want to put this else right where it is? Nico says it's some kind of another variable. It's a good guess, but it isn't. Else is a built-in instruction. I'll get yours in a second, Curtis. Else is a built-in instruction in Python. Python is going to know that you're not talking about another variable. Curtis said it needs a row space. So, and again, I don't want any of you typing right now. Okay. But Curtis, do you mean like that? Give me a yes or no. Okay. Good, excellent. He says yes. All right, that's not 100% either. Let me explain why. I'll go ahead and put it back where it was, okay? Now, again, I don't want you guys doing it. I'm just trying to illustrate a point here. This is why it's super important. We can read this because it reads, like I said at the beginning when we were talking about Python, notice there was that thing on the slide that said it reads almost like English, and it does. We, as thinking people, can look at this code and go, oh, well, this kind of makes sense. Look what Erik wrote. He said, well, if this player X in a row is equal to 4, then we're going to print, yay, player X wins. Else or otherwise, and then we would have something else underneath there. You're probably going to print no match, player O's turn, whatever we're going to type. That's what we can figure out because we're intelligent human beings. Remember this, computers can only do one thing at a time. They're stupid, and they can, this is the important point, they can only do what they've been told to do. Now, let me tell you exactly what the computer has been told to do. This is really important, so follow along, if you will. On my line 13, the computer has been told, please check a condition for me. And the condition is the value of player X in a row equal to 4. So the computer has been told, please check a condition for me. The computer has also been told, if the condition is true, then check the lines immediately below this and do the instructions that are indented. If they're not indented, don't do them. So I'm going to put a bunch of gibberish here. Let's pretend those are actual real lines of instruction. Again, Python is saying, hey, check the condition here. And if the condition is true, do all of these things that are indented. But as soon as you reach an instruction that is not indented, don't do that instruction. Only do the indented ones when the condition is true. So now, that's why if you were to put the else right here, it is included in what to do only if the condition is true. And so if the condition is false, we're never going to see this instruction. The computer is never going to perform it. It's never going to be able to have any alternative. So what do we need to do? We need to put the else back here. And this is super important. When I learned Python years ago, and this is one of the things that tripped me up. And I've taught Python for decades. This is one of the things that trips people up. Because we can read it, and the logic makes sense to us as human beings. But computers can't read. They can only do what they're told to. And what they've been told to do is, if you have a control instruction, if it's true, only do what's indented below it. And that's all. And if it's false, then check the next thing. Well, our next thing is the else. So type an else and then a colon, and then hit enter. Notice our editor has been very friendly as it indented things for us, because here's where to put the instructions that will be done only if the condition is false. Only if this condition is false. So what are we going to do? Well, again, in the actual program, there'll be a little more complicated logic. We're just going to print print. Sorry, it is player O turn. Now let's run this. Now, I'm going to take you through this one more time because this one of the things you need to start to learn is how to think like an engineer, how to think like a computer programmer. And computer programmers, the way we think is influenced very much by how a computer program is run. And a computer program goes like this. It hits line 13. It evaluates this condition. If the condition is true, it only does what's indented down below it. If the condition is false, it skips over these indented ones and goes to the next instruction that is not indented. In this case, the instruction is else, which means if this is not true, and it does everything below it that's indented. All right. So someone put in the chat, how could we make, what change do we need to make to this program right now to make it print out, yay, player X wins? What change needs to be made? Put that in chat. Curtis says player in a row needs to be 4. Spot on. Go to a player in a row. For me, it's line 11. And make it 4. And then run this. And boom, yay, player X wins. All right. Now, Keith has a more accurate answer, and I like this. But it goes into something that's just a little bit more complex for the time we have right now. He says a counter needs to be added to, or a counter needs to be added to determine that 4 has been reached. A counter is just using a variable and adding something to it each time an incident occurs. So he's right, but that's a little bit more complex than what we have time for tonight. The simplest thing is, hey, let's just pretend by changing the value of the variable that we do in fact have 4 in a row. Yay. All right, now I'm going to show you the next part a little more quickly just in the interest of time. So if you follow along, that's great. If not, it's totally cool. We've talked about an entrance point, like the first instruction, right? We've talked about variables. So we use this variable player 1. We can change the variable value. We use another variable. We use this variable for making control and branching statements. So we've covered some of the fundamental elements of any computer program. Now I'm going to show you how to do the subprogram part of it. We have represented in these 4 lines a decision that's going to need to be performed over and over again. Every single time player X takes a turn, we need to run these 4 instructions. Now, again, these are very simplified instructions, but the logic applies every single time. Every time player X takes a turn, we need to figure out whether they now have 4 in a row. And if they do, then they win. And if they don't, it's player O's turn. We're going to have to do this over and over and over and over again. This is a perfect candidate for a subprogram. Now, in Python, subprograms are called functions. So, backspace 1, and then hit enter just to give us some breathing room on the page. We're going to make a function. You use an instruction that is def. That means define. You're going to define a function. Then we give the name of the function. And I'm going to call it check if 4 in row. Check if 4 in row. I like that. That's a very descriptive function name. Now, functions sometimes need information in order to do their job. You put that information in parentheses. What information does it need? Well, it needs the current number of matching X tiles. In other words, it needs this variable player X in a row. So we're creating a function. We have a name for it. Check if 4 in a row. Oh, check if X 4 in a row. This is for player X. So check if X 4 in a row is our function. It will be given some information. And now we're ready to write down, okay, when this function, this subprogram, is called upon to be performed, what do we do? What are the instructions? Well, to enter those, you put a colon and you hit enter. And this is going to be not shocking to you. Everything that is indented after this line is inside the function. Everything that's indented is that set of repeatable instructions that we can call on over and over again. So to make it fast, I'm just going to copy them. I know that they are these instructions. And that's how you do it. Look at this. Here's the instruction that defines or creates a function. It uses the Python word or instruction define, DEF. It gives a name for the function. It gives the information the function needs. That's called a parameter. What information does this function need in order to do its job? And then it has the 4, in this case, the 4 instructions to be performed. And this part's super important. These are the instructions to be performed if and when we ask for this function to occur. If and when we ask for the function to occur. If we don't ask for the function to be performed, then these instructions never get used. We have to ask for check if X 4 in a row. We have to ask for this function to be performed. Only then will it be run. So for example, go to the very bottom, make sure that you're all the way at the left-hand side, and we're going to change the value of the variable player X in a row. PLAYER X in a row. And we're going to say that it's 3 in a row right now. Player X has three tiles in a row. Now, before we do anything else, I want everyone to put in the chat, what do you think is the final thing that's going to print over on the right-hand side? Put down exactly what you think the final line is going to be over on the right-hand side. Give me a guess. I'll keep it anonymous. What do you think? I got a sorry, it's player O's turn. I got another sorry, it's player O's turn. Good. Yes, you're all exactly right. Sorry, it's player O's turn. Except that you're not. That's wrong. Let's run this. And look. Yay, player X wins. Now let's talk about why. Remember this. This goes back to the fundamentals. A computer can only do one thing at a time. It starts at the top of the program and goes through one instruction at a time. So we all know that on line 11, we set player X in a row to 4. And then we know we have a condition that we checked. And in fact, player X in a row was equal to 4. And so we printed yay, player X wins. Then we created this function called check if X 4 in a row. And after we created the function, we changed player X in a row to 3. So have we ever actually run this code right here, did this ever execute? And the answer is it didn't. Why? Because a function is, this is super important. A function is potential behavior. It's some instructions that might occur in the future, but they'll only occur when you ask them to occur. We've never asked them to occur. We've just defined what would happen if we were to ask. This instruction, define, creates potential behavior. It creates the definition of a function. In order to make the function actually happen, you have to ask it. How do you do that? Go to the very bottom, hit enter a couple of times, and you just type the name of the function. Now, I'm going to use copy paste because I want to be safe. I don't want to mess up the typing. I'm going to copy the name of the function and I'm going to paste it down here. That's the name of the function. And I'm going to put in here player X in a row. Player X in a row happens to be 3 right now. We can see that right here. And now when we run it, it does in fact finally say, sorry, it's player O's turn. Let me know in chat if that made sense, if that helped clarify it for you. Give me a yes or no. It's fine if it didn't help. Figure out a way. Good, I got a yes. Yes, okay, good. Excellent. I'm glad. Okay, and again, all of the code you see on the screen is really simple, and I've kept it simple for a very specific reason. The fundamental principles of programming are much, much, much more important than you may have been told. And once you grasp the simplest fundamentals, then you can start to layer more and more complexity on top of them. But most technical instruction material comes in at too high a complexity level, and it assumes too much prior knowledge on the part of the student. I've made that mistake before when creating training materials. So I know how damaging it can be. When we teach at the Tech Academy, we teach the fundamentals extremely well. And then we layer a little more complexity on top, and then a little more, and then a little more. And very rapidly, you're at the point where you can work with really complex stuff and grasp all of it because the foundation was put in so well. So with that said, let me give you the actual full code. Christine, can you drop the link to the full code into chat? If you can't find it easily, I can grab it. There it is. Awesome. So you'll see all this content right here. Go ahead and copy all of it. Control A, Control C, and then erase all of the code that you just created in your code editor and paste in the new code. And then once you've done that, just take a minute and play the game. All right, I won. Woo! Man, I was a fierce player at Connect 4 when I was a kid. I would play my sister, who was 4 years younger than me, and I was vicious, like very competitive. All right, good. So let's take a very brief tour through this code. You have this code now. It's yours to keep. Mess around with it. Tweak it. Do whatever you want. Okay. I want to point out only a couple of things. One is that the very first instruction is something we did not cover. This is a Python instruction called import. Import lets you bring in computer code that someone else wrote and use it in your program. In this case, there's a collection of code called random. We call these libraries. It's code that someone else wrote. They wrote a library of code. And you can bring in this code and use it in your program. This code library called random works with random numbers. Not a surprise. Then, what do? Well, we create a bunch of functions. Notice this DEF or define. We define a function initialize board, a function print board, a function drop piece, right? Check win. Check win is kind of what we were doing, right? We were checking whether or not we have 4 in a row. Now, it's a lot more complex because we have both horizontal. We have horizontal and vertical, but all this code does right here is check whether or not we have 4 in a row. Now, there was no way in this class I was going to help build this complex logic. So we just substituted, is it 4 or not? But it's the same principle. At the center of all of it is an if. Now, there's lots of terms here, lots of Python instructions that you're not sure of the definition of yet, and that's fine. This is an hour-long course, but the basic concept is there. We've made a function. It has some control instructions. It has branches. And there's more functions. And this is the main function. Relatively complex, but it's just got like if and else. It's got print. You could read through this, and with a little bit of Google searching, you could start to understand how this program works. And finally, we have the very bottom, and this is where we call the function called main. When we call the function called main, it runs this. And this, in turn, calls the initialize board function. It calls the print board function. It calls drop piece when it needs to. It calls computer move. All these other functions get called by this one. So you see, this would be fun to kind of go through and search out and figure out how does it work. All right, so that's yours. Now, let me continue. And we're going to move pretty rapidly in this in respect to your time. It's gone a little bit longer, and I did see some questions, and I tried to handle them as we went, right? If you have further questions that I didn't get a chance to answer for you, we're going to give you an email you can use in a few minutes to send in your questions. I do get those, and I do answer them. All right, now, let me tell you a bit more about who we are, what we do, and see if what we do at our school could be a fit for you. And please stick around for our free gift. It'll be here in just a minute, okay? We offer 12 coding boot camps, and they're all online. They cover a huge range of technology subjects: AI, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. You can see them all on the screen here. We, in fact, have more certification programs than any other coding boot camp on earth. And here's what our programs are like. They're self-paced, but also instructor supported. They're flexibles. They're flexible. Students set their own schedule, and they can enroll 365 days a year. The content is well-rounded. It's in depth. They're affordable. All of our programs include job placement training and job placement assistance, and that's huge. But most importantly, our programs are designed for absolute beginners. No technology knowledge or experience is required, so you don't have to be a nerd to get through these programs. And who are these programs for? Well, anyone looking for a better career. Tech is a great industry to work in. There's remote work opportunities, you have better work-life balance, and technology pays really well. We consistently land on every major best coding bootcamp list. Our average review rating across all the major bootcamp review sites is 4.8 out of 5 stars. And that's based on student and graduate feedback. We're really proud of that. So I said that tech is a really good field. Here's some specifics. Again, you can get really good work-life balance in tech. Rarely do you work for a company where you're working 60, 70 hours a week or something silly like that, right? And there's a lot of remote work opportunities available, especially now after COVID. It's also a very creative industry, an industry where you can take a lot of pride in your work and you work with really cool, bright people. It's actually really awesome. It's also a stable industry that pays really well. And if you keep on learning and applying yourself, you can get regular increases in pay. The ceiling in tech is a very high ceiling, which is pretty cool. That said, when it comes to boot camps, these intensive training programs, there's some barriers to entry. One of the biggest ones is money. Boot camp tuition can cost thousands of dollars. So what we've done is we offer multiple financing options, including a big upfront discount if you just pay upfront. Or if you can't do that, we have monthly payment options for any credit situation you happen to be in. I will say this, I consider that getting through a Tech Academy bootcamp is an investment in yourself. I firmly believe that to be true. You're giving yourself a set of skills that are very valuable. They're valuable because of two things. You have skills that people either can't do or don't want to do, but they need them, and so they'll pay well for them. Now, another barrier to getting through boot camps is time. There's a lot to learn in a short period of time. Some boot camps handle that by training people in cohorts. They take a full group of students, they all start on the same day, and they all move through material at the same rate. People don't learn at the same rate, though, so we don't do it that way. And by the way, other boot camps require you to be in person in a building. Our programs are all online, and you choose your study schedule. It's self-paced. You can even do a part-time study schedule, which means you can study concurrently to holding down a job or going to school. One final barrier I want to talk about in terms of doing a boot camp is that you do need to have some technical interest or ability. But here I want to stress, you may have gotten some kind of an idea along the way that maybe, computer programming is too complex for you, or like maybe you're not smart enough for it. Not true. If it seemed like some of the technology educational materials you've tried to get through are too hard, that's not a you problem, it's the materials problem. And in fact, it's because, like I said, educators sometimes assume too much knowledge on the part of the student. We don't do that. At the Tech Academy, with our boot camp, you don't have to be a nerd. You don't have to have any technical background to enroll. So, are you working a dead-end job? Or maybe even unemployed? Is it important to you to work from home or to have more time with your loved ones? In other words, is it time for a career change? Because if it is, well, we can be the solution. We're career change experts. The bridge, that orange bridge in our symbol, is there for a reason. We're trying to provide a route into technology for everyone. And at this point, we have over a decade of experience in breaking people into tech. Most of our graduates make $30 an hour on average in their first job. That's $60,000 a year. And it's not just a few. We have over 1,000 graduates working in technology at everywhere from small companies to really big companies like Nike, Facebook, Disney, Uber, Epic Games. So as a reminder, we have open enrollment and you can start anytime. Now, this is the first day of June. What I'm about to show you was only approved for May. But I've talked to my co-founder, and for the next 2 weeks, we'll keep this active. What do I mean? Well, if in these next 2 weeks you enroll, if you pay upfront, you get a 50% tuition discount, half off instantly. Also, if you pay upfront like that and you happen to need a laptop, we'll give you your own refurbished laptop. Also, if you enroll in the next 2 weeks, there's no sales tax. Doesn't matter where you live, we'll handle the sales tax. Also, if you enroll in the next 2 weeks, we're going to ship you all of our technical books. And these are really, really vital books that we put a lot of work into. We have an introduction to coding book. We have a computers and technology simplified book. And we have the technology basics dictionary. It explains thousands of complex technical terms in a very simple manner. We'll also give you our career planning guide. This is a thing of beauty. Jack and I put the accumulated knowledge of like 25 or 30 years combined of working in tech into a career guide that tells you exactly how to plan the first 3 years of your career once you break into tech. It's really valuable. And we give you that for free if you enroll in the next 2 weeks. And finally, well, not finally, actually, if you enroll, like I said, in the next couple of weeks, you also get 3 months free access to the Tech Academy Accelerator, these weekly workshops that I do, which are a blast. And you've got free mini courses in there and free educational videos, right? And now finally, you'll get unlimited job placement assistance. As long as it takes to get you hired, we will work with you. So we haven't put this together. It did really well in May. We're really happy with it. So we decided to extend it for 2 more weeks because it was just going to be a May special. So that's there for you. So again, stick around for your free gift. It is coming. Christine, can you put the link in the chat? There you go. If this is a fit for you, or you even think it might be a fit for you, take the step of talking to our admissions personnel. Fill out that link right there. There's a little form at that link, the learncodinganywhere.com/Erik. Fill out the form. It's really quick. And after the form are a series of steps about the school, like videos and articles and optional steps to contact admissions, just to find out who and what we are, how our programs work. So I'm going to give a minute for anybody who wants to fill that out. Time to do so. I'm going to take a sip of water. All right, a couple quick helpful notes, and then we'll get you a free gift. One helpful thing is that we do have a referral program. Our graduates love us. And so for years, referrals have been one of our top enrollment sources. And so a long time ago, we instituted paying referral fees, a 5% commission payment for all enrollments. This isn't just for our graduates, though. You can do this too. So in a moment, we're going to give you an email that, for how to get your free gift. You can refer people to the school in that email. We will keep track of that referral. And if they enroll, we're going to send you a check for 5% of their tuition, which is pretty cool. We mentioned books. We've got 7 publications, including 3 Learn Coding Basics in Hours books. We have a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and the book You Are Not Stupid, which rocks. It's our biggest book by far. It's basically a written version of our most popular course in our boot camps called the Computer Basics course. It explains all modern technology terms and concepts. They're defined well. And the book even includes a history of technology, and it shows you how we arrived where we are today in tech, which is pretty cool. So here's our free gift. We will give you your own physical copy of our Introduction to Python book. This book rocks. We put a lot of work into this. It goes into much, much, much more detail than we could cover in this short period tonight, right? You get even more detail on the 5 fundamental elements of any computer program. A lot more data, information about the built-in instructions in Python and how to use them and all the different types of data you can work with. When you're done with this book, for example, you will be able to read through that program that we gave you the full code for, and you'll be able to understand virtually all of it. So if you want a copy, just email us. Christina, can you put the email address in to chat? There you go. Grab that email address, books@learncodinganywhere.com. And if you want a physical copy, this is for the US only, sorry. If you want a physical copy, send us in your name and your full mailing address, and we will send you a physical copy of the book. We love sending these out. We're happy to do it just as an acknowledgement and thank you for attending the free class. So do that. And you can also email questions on that same email address. You can email referrals, whatever you need to. So I'll wait a moment for people to grab that email address. And then we're going to give you all of our links. All right. Now, Christine's going to drop a link into chat. It is our Linktree link, right? If you're not familiar with it, click on the link and you'll see it. It's just a single page that has all of our links, our free educational YouTube video playlist, our books, our dictionary, our upcoming meetups, our social media accounts. All the links are there. So please follow us on social media and invite your friends to future meetups and tag us. Let us know that you see us out there on the internet. Now, here's a specific thing on that. If you'd like a chance to win your own copy of You Are Not Stupid, this is a book I always wanted to exist out in the world, and no one wrote it. And so Jack and I wrote it. It took us 1.5 years. It's a really good book, okay? If you want your own copy of this, and it's a pretty hefty book, you can win one. All you have to do is share a link to our next event on your social media and tag us. That's all. Doesn't matter what platform, Facebook, Twitter, or X, sorry, Instagram, wherever you just share it and tag us. We're on all the platforms. If you do that, then you're entered in a chance to win a copy of You Not Stupid, and we give away one of these a week. All right. Thank you so much for attending. I super appreciate it. There's a lot of things you could be doing on your Saturday night, and you chose to go through this coding thing with me. I hope it was of help to you, and I'd love to see you at our future classes. And also check out the accelerator. There's so much fun, and we get to do such a deep dive in the accelerator. So thank you all for attending. Really appreciate it, and I'll see you at the next event.